Kia ora, Year 12. This is a good integration by substitution question for maths, and I'm going to go very, very slowly through the first part where we have to do some stuff with changing over limits. And you just need to make sure that we don't miss any steps out in our working because it is a show that question. Okay, so we want to make it really, really obvious what we're doing. The second part is not too bad, but again, you just have to be careful not to make small mistakes. So let's just start by having a look at the substitution we're told to use. We're told to use u equals this and put it into here. So we'll start off with just writing out what the integral is. And we're given u is equal to 2 minus x to the power of a half. And I'll start off by differentiating that. So du by dx gets me negative 1/2 x to the negative 1/2. And I'm going to want to replace the dx. So what I'm going to do now is straight away split up the fraction into this. So we get du by dx is equal to negative 1 over 2 root x. So du is equal to negative 1 over 2 root x dx. So we might want to manipulate that a bit more. I'm going to come back to that after I've had a look at the other bit. Okay, but we're probably going to want to go dx equals blah, 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 but let's just see if anything falls out first. So the first thing that I'm going to do in here is look at those limits and see what changes we need to make. So my x limits are 1 and 0. U is equal to 2 minus root x. So that gives me 2 minus 1, which is 1, and then 2 minus 0, which is 2. So you can see that the limits have switched from the big one being the top limit to the big one being the small one. So that's one thing we're going to have to fix up. This here is going to be replaced with u, but we're going to need to rewrite root x in terms of u. Okay, so just shrinking my screen down a wee bit, we've got u minus 2 is equal to negative root x, giving us 2 minus u is equal to root x. So the last thing we're going to have to do is to do the dx replacement. So dx is equal to, or negative dx is equal to 2 root x times du. And we know that we can replace that root x with 2 minus u. So we get negative dx is equal to 2 times 2 minus u du, or dx is equal to negative 2 times 2 minus u du. Sorry about that noise, that is the dog snoring. Okay, so just checking off that we're ready to substitute everything now. We've got our dx, so we're ready to change over the dx. We're ready to do the limits. The denominator's easy, and so's the numerator. So putting all of this together gives me I is equal to the integral between 1 and 2. So the root x becomes 2 minus u. The 2 minus root x becomes u. And the dx becomes negative 2 times 2 minus u du. So working slowly through this, we're going to take the negative out the front. So we've got the integral between negative 1 and 2 of 2 times 2 minus u squared on u du. Now it's a show that question, so let's go back up and see what we're trying to show that exactly. Yep, so we want to show this. So there's only one step left to do, and it's just to switch the limits. So here, this equals this. And I'm just going to write a note saying since the integral between a and b of f of x dx is equal to negative that. Now I'm doing that because it's a show that question, and I think that makes it really, really clear that you get why you've magically switched those limits over. Okay, I guess the other way you could do it is just to write negative 1 here times negative 1. but I think it's quite good to show that understanding. So that's us done for that first part, so as required. Now the second part is not so bad. I just have to carefully expand out my brackets. And again, it's a show that question, and we're going to end up with showing that the integral equals 8 log 2 minus 5. So Max, I know you didn't need this part done, but I'll do it for everyone else anyway. Right, so the integral is from 2 to 1 of 2 times 2 minus u squared over u du. I'll take the 2 out the front, and I'll now expand out this. So we get 4 minus 4u plus u squared over u du. So it's going to be a nice easy integral. That gives us 2 times the integral of 4 over u minus 4 plus u. Right, leaving us with 2 times 4 log u minus 4u plus a half u squared, evaluated at 2 and 1. So we get 4 log 2 minus 8 plus a half of 4, which is 2, minus, well, the log of 1 is 0, minus 4 plus a half. So that gives me 2 times 4 log 2 minus 6 plus 4 minus a half. I'm going really slowly. So finally we get to 2 times 4 log 2 minus 2 minus another half. So minus 5 over 2, which gives me 8 log 2 minus 5 as required. So there you go. So a few things to watch out for with substitution in this question, right? So the main one in here was that the limits had to be switched over. But the other thing that is worth watching out for really carefully is that the dx needed a bit of work to be switched over in terms of u. Okay, and you don't always have to do that straight away. You can leave that to be the last thing that you do after you've sort of made x the subject of the thing with the u in it. Okay, so send in any questions you've got. I'm free on and off most of the afternoon. I can also jump on Google Meet for anything that's better done that way.